Tutorials. I, Dr.Ashwin Dobariya, welcomes you to Programming in C practical video series. In these videos, we will discuss one programs that is interchange two numbers using bitwise operator. In our previous video, we have seen two different programs, similar type of programs where we are interchanging the numbers but using third variable and without third variable. But this is something like a unique programs where we will interchange or swapping two numbers but using bitwise operators. So let's see the definition of this program. Write a C program which takes input of two numbers and interchange or swapping its value using bitwise operators. So here the bitwise operators. So friends, to understand this program, you should have the knowledge about the bitwise operators. Here I am trying to explain because the detail operator concept will see in the upcoming videos in the theory video. So first of all, we'll think about how many variables we require to do this program. So here we want to interchange two numbers, so we require two variable x and y, and we assume that the value of x is 5 and value of y is 10. So in this program we will input these two values, two variables. So step number 1, input two numbers to our programs, and what is the logic that we'll discuss one by one over here. And after this logic, the output should be the interchange value. It means x value is 10 and y value is 5. This is our output. So how we can do these programs? And as I told you that bitwise operator, so the concept of bitwise operator is it directly perform the operation on bits. Now what is bit? So bit, it's a concept of binary digits, right? Binary language, you can say. So generally in our day-to-day life we are using the decimal number system. So here you should have a knowledge of number system: decimal, binary, hexadecimal and octal. But here hexa and octal will not discuss. Here we will discuss about the decimal and the binary. Generally as a human or as a user, we are using a decimal number system in our regular routine work. But computer generally works on the binary. So binary digits are 0 and 1 bits. So bitwise operator generally perform the operation on bits instead of the decimal value. So how it perform internally, that logic I am explaining in this video. So here, as I told you that to perform this program we require two variable x and y. Let's we assume value x value is 5, y is 10, and both are numbers, so integer is the data types. So how this bitwise operator actually work? So okay, 5 and 10 are decimal value, but first of all the compiler internally converts this decimal value into binary digits. It means bits. And just I am explaining the very shortcut method how we can convert any decimal value in binary digits. So binary digit is having either 0 or 1. So here decimal is 5. Now here you have to write one number series like 1, then you multiply 2, so 2, again 2 multiply 4, again you multiply 2 means 8, then 8 multiply to 16, then 16 multiply to 32, then 64, 128. In that way you write down the number series. Now what you have to do? Suppose you want to convert the 5 decimal value in binary. Then here you have to just perform a sum. Which number sum is equivalent to 5? So 1 plus 4. So 1 plus 4, it means 5. So what you have to do? Here in addition, these two numbers are participating, right? So 4 plus 1, it becomes 5. So here you have to write in place of 1 1 and 4 1, right? And remaining you have to mention 0. Similarly, how we can convert the decimal value 10 into binary? So first, which are the numbers are participating in a sum? So we can say 8 plus 2 is 10. So 8 is participating, so in place of 8 it consider 1, and in place of 2 is consider 1, and remaining is 0 0. So in that way you can convert any decimal number into binary. If you want to verify using calculator, then you can verify. See, if I say 5, then in decimal 5 is there, but in binary it is 0 1 0 1. So see here, you can say 0 1 0 1. If I input 10, for example, 1 0, so now see decimal value is 10. Now what is the equivalent of binary? 1 0 1 0. Now see here it is 1 0 1 0. Now if I ask you a simple question, what is the binary of 17, for example, 1 7, right? So here 16 plus 1 means 17. So we have to keep 16 place 1 and 1 is 1, right? Remaining is 0 0 0, right? So 1 0 0. So if we check that, what is the equivalent of 17 number? So 17 means, see here, right? This you consider as a binary. 117 instead of 117 we have to write 1 7 only. 17. So see 1 0 0 1. So 1 0 0 1, right? Like this. So first of all, our decimal value is converted into binary in bitwise operator. So here x value of x is 5, so it represents in binary is 0 1 0 1, and value of y 10. So 10 equivalent binary is 1 0 1 0, right? And output should be reverse. So let's see the step. The first steps, we have to write x or y. So here x and y both are variable, and this XOR is the bitwise operator. There are many other operators are there, and, or, negation, XOR, and one of the operator of bitwise operator is XOR, right? So here to interchange two numbers, here we will use the XOR operator. Now how XOR operator actually work? So suppose if we perform the XOR operator between x and y variable, then first the binary value of x is 0 1 0 1, then binary value of y is 1 0 0. Now if both the inputs, or you can say both the bits are 1, then and then output is 1. If both the bits are 1, then and then output is 0, otherwise output is 1. So here say 1 0 1 0 1 1 1 0 1 and 0 1. So here both the bits are different. Here 0 1 1 0 0. So output is 1 1 1. So the first steps here, x or y, right? It converts in binary bits, then it apply the XOR, and in XOR if both the bits are 1, then the output is 0, and if one of the bits is 0 or 1, then output will be 1. So that is the output of XOR, right? So this is the meaning of XOR. If both the bits are 1, then and then it generates 0, otherwise it generates 1, right? So first steps is we have to perform XOR operators on both the variable x and y. Now what is the next? So now see, the latest value of x is 1 1 1 1. So here latest value is 1 1 1. Y will remain as it is 1 0 1 0. Now in step 2 again we will perform XOR operator on the same variable x and y, but here in second step we will assign the output into y. Now see here 1 0 1, because it's a XOR, 1 1. Now see here both bits are 1, and when both the bits are 1, then XOR gives the 0 bits. Now here 1 and 0 1. Now see here both the bits are 1, then XOR will give you a 0. So and this output will be stored into y. So now the latest value of y is 0 1 0 1. Now see 0 1 0 1 means if you convert 0 1 0 1 from binary to decimal, right? Then binary to decimal means how we can convert binary to decimal. So see here 0 1 0 1. So 0 1 0 1. So it is equivalent to 5. So internally y becomes a 5. So now see our first target is achieved. 5 is transferred to y because now y is 0 1 0 1, right? Similarly the third steps again we perform the XOR operations, and now in third step we will assign the value to x. So here x will remain as it is. Latest value of y is 0 1 0 1. Now we perform the XOR operation. So 1 1 both bits are 1, then it gives 0, then 1 0 give 1, 1 1 both are 1, then 0, and 1 0 means 1. Now 1 0 1 0, again if we consider 1 0 1 0, it is equivalent to 10, and 10 is assigned to x. So now see here, internally x becomes, we have used 3 steps in a logic using x bitwise operator. So here XOR operator is a bitwise operator. So first we have performed XOR on 2 variable, assign the value to first variable, then we perform the same XOR operation and assign to the second variable, and again we perform the same operation and assign to the first variable. So here everything is performed on a bits, and finally once the compiler execute these 3 statements, then the original value will be interchange of both the variable. Let's see these programs in a turbo, see how actually it works. So here first we have to include a 2 header file, stdio.h and conio.h, and in main function here we require 2 numbers, 2 variables, so x and y both are declared as an integer. Then clear screen which clear the old outputs, and first we'll ask the one number which is which will be stored into x variable, and second value we will input and it will be stored in a y. So first we will input 2 number, one first number in x, second number in y. After that, this is the actual logic of this program where we are performing XOR, and this caret symbol is the symbol for XOR operator. XOR operator, that is the bitwise operators. So first we perform XOR, assign to first variable, again we perform XOR operation, then assign to second variable, again we perform same and assign the x, and after that if you print the value of x and value of y, then it will be interchange. Now if I execute this program using control F9, if I input 5 of x value and y is 3, now see the x become 3, y becomes 5. If I run this program and again I input a different value, suppose x is 20, y is 70, then see x becomes 70 and y. So here the difference is that the operation is directly performed on bits, not perform on decimal value. So internally first it converts into bits and then after it perform the XOR operation. So friends, I have also given this source code in this video description part. So link is available in the video descriptions. You can download this source code and you can do the practicals in your desktop and laptop. So I hope friends you enjoy this video, and in this video description part I have also given the other theory and practical video links for your reference. So friends, like this video, share this video maximum to your friends so they can also get the benefits, and in next video we will discuss one another program, that is C programs to calculate sum of first and last digit of the number of 3 digits. Suppose if I input 125, then 1 and 5, 1 is the first number, 5 is the last number. So we will, how we can separate first number, how we can separate last number, and then after how we can calculate the sum. That video will discuss in the next video, that program will discuss in the next video. So please friends, subscribe this channel's video for getting the updates of upcoming video. Thank you very much.